We're going to take a little look at containment, and containment is something that you will use if there is a relationship between your classes, but it's not an is-a relationship. Uh, Containment is also called containerization, and when you have a has-a relationship is when you will use containment. And it involves taking an object or creating an object from one class inside another class. So it is helpful to look at examples so you can understand how this all works. So my first example, I've got a pet class and an owner class. And an owner has a pet, or a pet has an owner, whichever way you want to look at it. But I'm going to take a pet object and place it into my owner class. And that is what I've done. So I am using properties here, public properties. And if you remember, behind the scenes, a public property is going to create a private field. It will create the get and the set method. Okay? And then what you use in your program is the public facing property. So for pet, I've got 4 properties. Then down here in owner, I've got 3 properties and I've added a pet object. So I've got my pet class here and I'm calling the object itself pet. And I could have named it whatever I want, okay, but I just chose pet. And then to display all the information, I did create a display method. To display my properties that are in owner, I can just use the property name. Okay, so that's pretty straightforward. To display the pet information, I have to use the object, which is pet, a dot, and then the property that I want to access. So you can see how I have done that here. Then in my main program, there's a couple different ways that you can code this. What I did is I created a pet object and I used an initializer list. Okay, and we learned about those with collections. Okay, you can use those with objects as well, where you just take your property and set it equal to the value. And you'll notice that there's commas after each property. And then after the last one, you omit the comma and you put a semicolon after your closing brace. So I've created my pet object, which I again called pet here. And then I create an owner object, which I very creatively called owner. Okay, and then I set the different properties equal to values. When I got to the pet property, I set that equal to my pet object, which is filled in. Okay, and then I call the display method and it'll display all of that data back. Okay, so that is one way of handling this. I actually copied that into a program, and I'll show you another way to handle this. So you can see I commented out the pet object, and I went ahead and created the owner object, but I can't fill in pet yet because pet is an object. It has to be instantiated. Okay, so here is how I instantiate pet. So just owner.pet, pet equals new pet. And then I have to assign values to place data in those properties. So because the pet property is part of the owner class, I take my owner object, which I created up here, dot. I take my pet property, which is what I need to fill in, dot, and then the property from the pet class itself. Okay, so here's my pet object. And then there is my property. So technically, I'm taking my owner object. I am taking my pet object that is part of the owner class, a dot, and then the property I need to put a value in that is in that pet class. Okay, so what pet represents here is this property. Okay, so it is pet.name, pet.species, pet.breed, and because it's part of the owner class, I have to put my owner object in front of it. Okay, each of these, the end result is the same. The data gets filled in. It's just two different ways of doing it. So if I run this, okay, you can see the end result. And if I move the comments down here and I run it again, the end result is the same. Okay. Whoop. Although it does not like that. Oh, did I screw up the comments? Probably. Let me see what I did. Oh, I know what I did. I forgot to put this back in. There. All right, let's run it again. And there you go. Okay, so the output is the same when I when I put that line in. Okay, so that is one single object. Now we're going to look at another example, and this one is a car and driver class. And so we have one car and we want to be able to add multiple drivers. Okay, so a car has a driver. So this is clearly they're related, but it's not an is-a relationship. It's a has-a. Okay, so what I did was I created my little driver class here. Okay, and you can tell it certainly is little. I've got two properties, a constructor and a parameterized constructor. Okay, then in my car class, I've got three properties, and then I am creating a collection, a list of driver objects. Okay, and I think the browser kind of changed this code. Hold on. I'm going to fix that. Alrighty. The browser likes to hide things that I have in angled brackets if I do not put spaces in them. So when you guys code them, you do not need to put these spaces in, but my examples have to have them or they don't display. Anyway, back to the example. So I have a list of driver objects. Okay, so you can see I've got my list. My data type is the driver class, and I'm going to call this list of driver objects driver. All right. Down here in my constructor, I do have to instantiate this list. I don't have to give it any initializing values, but I do have to create it, which is what this statement does. Okay. And then in my parameterized constructor, I am receiving a driver. And so I'm just assigning that to the item that we are working with. Then as far as the display goes, it's pretty normal for everything up until we get into the driver. The driver is a list. And so I'm using a for each, which will automatically iterate through everything in that list. So I can print out all of the drivers. And to do that, I am using driver dot name and driver dot age. Okay, so that is how I'm iterating through. And if you remember in a for each, you are giving your all the items an alias. And in this case, I did driver with a lowercase d, which is why I'm using that to access the name and age properties. Okay, so that is my display. And then in my main method, I am basically instantiating a new car, and I'm asking for the make, making sure they enter a valid string, asking for the model, again, making sure I've got a valid string, asking for the year, and I am making sure they entered a number. Not only am I making sure that it's an integer number, I'm also checking the range for the year, okay, to make sure that they are entering a valid year. Okay, and then I am setting that year property. Okay, so this is all just the regular properties that are part of the car class. Then I get to this collection of driver objects. So I'm asking how many drivers, reading that in, validating the number. And my rules for driving drivers for one car is, well, the number can't be less than one, and it cannot be greater than five, and it has to be an integer. Okay, so that's what it's checking. And then once I have a valid integer, I am going through a loop and I instantiate a driver object, which I call driver here. And then I ask for the name and I fill that in, okay, and make sure that's valid. I ask for the age and I fill that in, making sure that's valid and the driver cannot be less than 16 or more than 100. And then I take my car object and the driver property, that list property that is up here. Okay. And then I use dot add, which is the method that you need to use to add to a list. And I have filled in driver, and that is what I add. Right? So I'm filling in the list, and then I'm going to display everything. Okay? So we'll go ahead and run this so you can see how it works. Okay, I've already copied it over here. And let's run it. Okay, car and driver. Let's see, make. I'm not very good with makes and models, so let's see. How many drivers? 4. Name, Lisa. All right, we're gonna fudge my age here. Let's see. Fudge and Dan's age. Let's see. Well, I guess we'll have to fudge everybody's ages. Let's see. There we go. All right, so then it loops through that display where it is showing you the information, and then it does that for each on the drivers. And so that is how you would add a list of objects. And this last example is probably the most complicated. It is a house class, and the house has um, quite a few uh, features that are not is relationships. So the regular properties in-house would be address and number of floors. Okay. And then from that point on, everything else are objects from other classes. So we have a kitchen class, right? We have a bedroom class, and we have a bathroom class. And I can see that my angle brackets and data types are missing. So hold on, I am going to get those back. Okay, so back to our house here. I have put spaces in these angle brackets, so now they display. And so you can see I've done a list of bedrooms and a list of bathrooms. I didn't do a list of kitchens, although, in a larger home, you may have more than one kitchen. But in this particular house, we don't. So that is my house. And then you can see in the default constructor, I had to instantiate kitchen, and I also had to create a new list for the bedroom and the bathrooms. Okay. And then what I decided to do for these is just override toString. And toString is part of the overarching class that basically all classes are derived from. But the default, as far as how it prints, is not very user friendly. So what I did here was kind of customize the printout for this. So I've got an output string, and I've got the house with the address and the floors, and even all of the kitchen information. Okay, this is how I'm doing the kitchen information. Um, and we'll take a look at kitchen so you can see how that works. And then you can see I've got a for each for the bedrooms and the bathrooms. Okay, so let's take a look at kitchen to see how I did that class. So up here I've got kitchen, and you'll see I did some enums up here for the different sizes. Kind of a generic size, a bedroom size, and a bathroom size. Then for kitchen, I've got some Booleans as far as the different features, dishwasher, oven, microwave, refrigerator, and size. So for size, the data type is size. So it's going to come and it's going to look at the enum values. Okay, and you can see for the default constructor, I set everything to true, and the size of the kitchen is medium. And then I've got the parameterized constructor where values are passed, and I override toString. Okay, and so what it is returning then is a formatted string with all of the values. And so what I did, because a lot of these values are Boolean, so what I wanted to do next to dishwasher and oven and microwave is display yes or no. So I use the ternary if else here. And so it's checking the Boolean. Okay. And remember, anything before the question is your condition. So this Boolean, it's checking to see if it's true. Okay. And if it is, it's going to print yes. And if it isn't true, it is going to print no. And so I've done that for each one. And then you can look for bedroom. Kind of set some defaults up here. For the size, I did medium. For the bed size it'll fit, I put full, and it has a closet. Okay, and for the bedroom, I'm just going with defaults there. And then I've got a parameterized constructor, and I did override toString. Okay, so you can see what it's going to return. And here for my Boolean, I did do that ternary if else. For bathroom, there's quite a few Booleans here as well, in addition to size. Okay, and so I just went with the default constructor, which I don't really have to set values in because it'll do it for me. And then I've got the parameterized constructor, and again I overrode toString. And by doing this override, it looks like I'm printing out the object itself. Okay, but when I do that, it'll automatically run through here. Okay, and this has got a lot of those ternary if else. Okay, and so when we come down here, you can see our main method is actually pretty short. I'm just creating one house. And so I set the address and the number of floors. Here I create my kitchen. Okay, and I am using the parameterized constructor for this. And because bedrooms and bathrooms are a list, I have to add to the list. So you can see I've got my house object dot, and my name of my list dot add. Okay, and then because this is another class, it's an object I'm adding, I have to say new bedroom, and then I'm passing it the values. Okay, so this is adding it to the list. Okay, but because it's a class, again, new bedroom. Okay, and I'm doing pretty much the same thing for the bathroom. Okay, and then the cool thing, because I overrode toString, I can make it look like I am printing out house. And house is my object. And it's going to go through all these different toStrings. So hold on, I'm going to copy and paste this, and then I will run it. You can see how cool this is. All right, so I've copied and pasted the whole thing. So let's run this. All right, so you can see it printed out my house information. And then here it's, and remember how I got this printout, council.writeline house. Okay, so what did it do? It went through toString for house. Okay, so that's how I get house and then the address, the floors and the address. And you can see I did a new line here with kitchen. And it looks like I'm just printing out the kitchen object. But what it's doing is it is running through the toString for my kitchen, which is right here. Okay, so it's got size, medium, and then we go through all of these little ternary if else. So dishwasher, yes. Oven stove, yes. Microwave, yes. Refrigerator, yes. Okay. And so then once it gets done with kitchen, okay, I've got a for each for the bedroom and then a for each for the bathroom. Okay, so you can see for the bedroom, it's going to have a little heading of bedroom, and then it looks like it's printing out the object. Okay, but what it's doing is it's going up to bedroom, which is right here, and it's going through toString. So you're going to see size. Okay, this one is a large, then it's got bed size king, closet, yes. And I must have an extra parenthesis, which I think I do. I got an extra parenthesis somewhere that I need to get rid of because I don't like that extra parenthesis. I don't think it's up here. So anyway, it's going through the bedrooms and printing out each of those. And then it does the same thing down here for the bathrooms. So that is how I am getting that output. Okay, so now back over to here. So what's the difference between inheritance and containment? Inheritance lets you inherit properties and methods from a base. The new derived class can override the functionality of the base if the base methods are virtual. The derived class can add data and properties or methods to what was in the base, and the inheritance represents an is-a relationship. For containment or containership, it allows a class to contain one or more objects of different classes as data members. The container class cannot override the functionality of the contained class. So we added the kitchen, for example. We can't change the kitchen class. We can only use it, okay? We can't override anything. We have to use it as is. And the relationship for containment or containership is a has-a relationship.